Hello and welcome to our webinar, which today focuses on how AI is turbocharging the patent process. Before we get started, and as people continue to join, I'd like to provide you with a brief introduction to Welocalize, today's topics, and our two speakers. Welocalize is a trusted global language services provider. We work with companies worldwide in a variety of industries to deliver innovative translation and localization solutions. Welocalize encompasses specialist practices in legal, life sciences, financial, and digital marketing. Our legal services team, some of you may know us as Park IP, provides expert language and translation solutions for global IP services and corporate matters. Global brands trust us with designing and managing technology-driven language programs, powered by machine intelligence such as AI, delivering faster processing of documents, electronic document review, and increased translation productivity across large volumes of content. And that's what we're here to talk about today, leveraging technology to streamline tasks and create more efficient and intelligent platforms for collaboration. Because while the patent process is notoriously slow, in this webinar, we will share how AI has the potential to speed it up. The volume of data, including emails, continues to grow at exponential rates. Big data is an issue across almost every legal function. For attorneys working on global litigation and e-discovery, it's not uncommon to manage documents containing 20 to 25 million words or 2 to 2.5 gigabytes per day to prepare for court. For cross-border cases, data often goes international and includes multiple languages. We have two speakers today that I'd like to introduce, Ari Blokland and Alex Janishevsky. After studying at Delft University, Ari Blokland has started his career as a journalist for a scientific paper. After a year, Ari began at AOMB and he qualified both as a Dutch and European patent attorney. Within AOMB, Ari is the leader of the business unit corporate and is also a member of the management team. Owing to his many years of experience, Ari has seen every aspect of the intellectual property spectrum. As such, he's able to guide his clients through the IP landscape and inform them about the different routes they can choose from. Ari is also a Dutch representative of the Institute of Professional Representatives before the European Patent Office. Also a representative of the Alliance Apex, Ari visits Japan and China several times a year. Our second speaker is Alex Janishevsky. Alex is Senior Manager of MT and NLP deployments at Welocalize and has been in the industry for over 15 years. He holds a PhD in Slavic languages from Brown University. Alex is a frequent contributor to industry conferences and journals. His most recent work is overseeing the development, testing, and deployment of Welocalize's plugin for the Relativity e-discovery platform. Let's take a quick poll before we move on. On your screen, you'll see a question and some possible answers. So the question here is approximately how many emails were sent each day in 2019? So you've got some options there, 126 billion, 293 billion, 525 billion, or too many to count. I'll just give it a few seconds to let everybody complete their answer, and I'll give you the answer shortly. As we can see, the numbers are creeping up. So the correct answer is actually 293 billion, of which 26% are correct. So thanks very much for that. Before I turn over to our speakers, I'd like to point out that the questions box to the right of your screen and ask that you feel free to submit questions throughout the session. Please confirm in the box which speaker you'd like to direct your question to, and we'll answer as many as we can at the end of the session. I'd now like to hand you over to our first speaker, Ari.
Thank you, Chris. Thank you for your nice introduction. Welcome to this webinar. It's an honor for me to speak to you about AI. I have a slide with an overview of the topics I would like to share with you. First, I would like to tell something about how does a patent process look like, because I am not familiar with the audience if the audience knows everything about the patent process, but it's essential to have a short look at it. The second point, which I would like to discuss with you, what is a search report? Because the search report is a very important thing in the patent process. And the third aspect is novelty. Novelty is some of the hurdles you have to take before getting a patent. And then point number 4, what is the role of the language? Because the language as such is very important in drafting a patent application and also trying to invalidate the patent. And then at the last slide, I will inform you why I think that AI is crucial in the patent process and what can AI do for you. So in the next slide, you will see an overview of the grant procedure before a patent office. This is just a general overview. It's not typical for Europe or US or Japan, but it's just a very introduction of a grant procedure before a patent office. Please note that the patent office is the government and it's not the private practice. Let's assume that you work in a company or you have your own company and you have something invented. First, what you normally do is that you do a kind of a pre-search because you would like to know whether or not it makes sense to file an application. Because if your invention as such has already been published, it doesn't make sense to file an application. So normally you start with a kind of a pre-search, which you can do in-house, but you can also outsource it to commercial companies. Let's assume that you file your application. That's on the left side of the drawing. Normally, when you file your application, you will get a filing date and a filing number. These things are very important. I will come up later on that. If you file your application, you submit your application, which means it's a description and claims and drawings to a patent office. And the patent office starts drawing up a search report, and the search report will be created by an examiner who works in the patent office. The search report is nothing more, nothing less than an overview of documents which are identified by the patent office as relevant or irrelevant. On basis of the search report, you can make a decision whether or not to go abroad. If you have a business case, which means that your invention may be useful not only in the US, but in Europe or China, Korea as well, you will file a foreign application. If you have a positive search report, you can imagine that such a positive search report will give a solid basis for further prosecution. However, if the search report is negative, which means that your invention as such has already been published by other people, then you can withdraw your application. And if you withdraw your application, which means that there will be no publication at all, not from the application, not from the search report. In a standard patent procedure, you will have your publication after 18 months from the date of filing. So if you file your application in 2018, your publication will be published somewhere in 2020. And the publication means that the patent office will publish all your documents in general, including the search report, including the documents. If you look at the patent procedure, the search report created by the patent office will be used as a legal basis for the examination proceedings, because the patent office will start the substantive examination based on the results of the search report. And in the search report, there are documents which have been examined by the examiner, and the examiner has to start the discussion with the applicant about two major things. First of all, novelty, and the second one is inventive step or obviousness. And let's assume that you meet both requirements, novelty, inventive step or obviousness. Then the patent office will issue the patent, and that means that you will have a granted patent. And after that specific period, which can take several years, you have the opportunity to enforce your right as a patent holder. But you can imagine that people don't like your patent, and then they have the opportunity to invalidate a patent. And invalidate the patent means that you start searching for documents which may destroy novelty from the patent or may destroy the inventive step requirements of the patent. You can imagine that the quality of the patents which come out of the patent procedure strongly depends on the quality of the search report. If the search report is not good enough, then the examiner will give his opinion on bad documents, which means that weak patents will be granted. If the search report is of high quality, which means that all the relevant documents are cited in the search report, you can imagine that it will be very difficult for other people to invalidate the patent after grant. So the search report is of crucial importance in this specific grant procedure before a patent office. And then we have to look at, next slide please. As discussed, the search report as such is prepared by the examiner, and you must understand that on average a US patent examiner spends only 18 hours reviewing an application, which includes reading the application, searching for prior art, comparing the prior art with the application, writing a rejection, responding to the patent applicant's arguments, and often conducting an interview with the applicant's attorney. If examiners are not given enough time to evaluate the application, they may not be able to reject applications by identifying and articulating justifications with appropriate underlying legal validity. And how does a patent examiner work on a specific case? In that context, I would like to tell you something more about how prior art searching takes place in practice. The purpose of the prior art search is to find the closest prior art that may impact the patentability of an application and the likelihood of getting a patent granted. In its simplistic form, the prior art search involves the following steps. The first step, examining the claims and identifying terms, possible keywords. And the second step is distilling what the defining part of the invention is and forming a search statement. The third step is identifying the most relevant classifications based on keywords and the examiner's background knowledge. And the next step is forming a search query by using keywords, classification codes, and Boolean functions. And then the examiner is trying to find the patents that are likeliest to be relevant to the application. And once the documents have been created, he has to sift through the retrieved documents to identify the most relevant patents. And after that step, further narrowing down the search results to identify close conceptual similarities. Maybe there is also an optional search for published online materials, and at the end, the examiner will form a conclusion, a judgment about the novelty and inventiveness of the application. The definition of the search statement is one of the most important steps in the process. It requires clear understanding of the critical subject matter and the potential novelty of the application. Examiners often modify the search statement several times as their understanding of the prior art or the potential patentability of the application develops. The search statement may include words which do not necessarily appear in the original claims. The most time-consuming step is sifting through the large number of patents retrieved. So the examiner plays a very important role in creating the search statement. And the examiner applies two different aspects of patent searching. The first one is novelty, and the second one is the state of the art. But you must realize, what does novelty mean? Novelty means that an invention is considered to be new if it does not form part of the state of the art. And what exactly is the state of the art? The state of the art shall comprise everything made available to the public by means of a written or oral description, by use or in any other way before the date of filing, and there are no restrictions whatever as to geographical location, language, manner, age limit for documents or other sources of information. And you can imagine that correct translations of documents are of utmost importance. And what we see in practice is that there is often a difference between a search report issued by, for example, a Korean examiner and, for example, a European examiner. The reason for that is the language. A Korean examiner has knowledge of Korean language. his European colleague does not have such experience. So the language background plays an important role in the documents the examiner will cite in the search report. And the introduction of AI will dramatically reduce the influence of the language. You have those translation machines, and those translation machines do not care about the English or the Korean language. So you can imagine that the quality of the search report will improve by the introduction of AI.
Ari, can you explain a little bit more about how foreign language impacts on this process for you for search reports?
Yeah. As just mentioned, we see a huge difference between the documents cited by an examiner working for the USPTO and an examiner working for the Korean Patent Office. And that's something which is really frustrating for the patent attorney and also for the applicant. And by introducing AI, there will be a lot of new documents in the database. And you can imagine that if the search query is created by AI, there is no human interference necessary for finding the relevant documents, because the language as such does not play an important role anymore. You can imagine that if you are familiar with the English language, you have a certain direction in finding documents. But if the language does not play any role here, you have a huge amount of documents which you can analyze, and you can analyze it much faster by a machine than by a human being. And I just mentioned that the US patent examiner spends only 18 hours reviewing a case. And you can imagine that if an examiner has AI on his desk, he can do the machine do the work, and which means that the AI tool can perform the time-intensive prior search much faster. And once that task is done, the patent examiner will be able to allocate a greater portion of the review to understanding the applications, comparing the prior to the applications, writing rejections, etc. So it will be a very step forward when the examiner can use AI for retrieving the relevant documents. Yeah. In my next slide, I have provided some standard aspects of basics patent jargon. When you have a discussion with an inventor, the inventor is talking about, for example, a spring. But if you are writing the application, the word spring is too restrictive. So you always use the word energy storing means, which means that you can broaden the scope of the patent by introducing such a more broader term. In this slide, you see other examples which clearly create a broaden of the scope of a patent. And that's important when you try to search for patent documents. You do not use the word spring, but you use the more general word energy storing means. And on this slide, you will find other examples for patent jargon, which is used to broaden the scope of a patent. Okay, let me go to the next slide. In this slide, I will tell something about what can AI do for you. First of all, it's all about the prior searches, and the examiners, they have to put the limited time on that specific task. AI tools can now streamline the application review process and the quality of the results by reducing the amount of time examiners spend on researching prior art. Instead of 2 to 4 days of prior art research, AI can do all that work in 1 to 2 hours. AI technology has advanced beyond simply comparing the words in a patent application to those in other patent records. AI can compare a whole patent's content and IDs against millions of other patent records and database sources to find relevant prior art and return search results that meet or exceed those of human examiners. Thus, even if examiners on average only spend 18 hours to search and review a patent application, with AI tools, they can perform the time-intensive prior art search much faster. And since the purpose of the Patent Act is to incentivize innovation for the short-term benefit of the inventor and the long-term benefit of the society, surely tools that redirect inventors' focus toward substantive matters are very valuable. Another aspect is the second bullet, is that you as a company, you can save money and time by identifying inventions that are not likely to be patentable. Before such a patent application even reaches the patent office, AI tools can save inventors time and money by identifying early on those inventions that will likely not be patentable. Instead of investing time and effort in such dead-end inventions, they can turn their attention to more promising work and consider the benefit to patent system and its goals if AI not only makes the examiners more effective, but also improves the overall quality of the initial applications. And the fourth bullet is talking about the improvement of the quality of the granted patents. As mentioned in the slide of the patent process, I discussed the quality of the search report. If the search report is of high quality, you can imagine that only strong patents will survive. So in case the search report is of high quality, there will be less weak patents. So that's also an important benefit of the AI system. And if you look at the following bullet, in which I talk about the Big Five IP offices, maybe you've never heard of it, but the Big Five IP offices is the name given to a forum of the 5 largest intellectual property offices in the world that was set up to improve the efficiency of the examination process for patents worldwide. The members of IP5 are the European Patent Office, the EPO, the Japan Patent Office, GPO, the Korean Intellectual Property Office, KAIPO, and the National Intellectual Property Administration of the People's Republic of China, CNIPA, and of course, the United States Patent and Trademark Office, USPTO. And these IP5 offices together handle about 80% of the world's patent applications and 95% of all the work carried out under the Patent Cooperation Treaty. The IP5 offices work together closely to improve efficiency and address the growing backlogs in applications worldwide. The heads of the IP5 offices meet annually to decide on strategy and review progress. The vision of this IP5 is that the elimination of unnecessary duplication of work among the offices, enhancement of patent examination efficiency and quality, and guarantee of the stability of the patent right. And they have defined their new view, which means that they would like to have a high quality and timely search and examination results. And you can imagine, by the cooperation between those Big Five IP offices, the quality of the search report will dramatically improve. And if, for example, the European Patent Office can use the search report prepared by the Korean Patent Office, which means that the examiner in the EPO does not have to go to the database to find relevant documents, you will imagine that the number of patent examiners working in each patent office will be reduced. So that will be an effect of the cooperation between the Big Five IP offices when those Big Five IP offices start their creation of search reports by the introduction of AI systems. And the other point which I would like to say, that by the introduction of AI into the patent search system, you will see that there will be a reduction of the time spent on the applications in the patent office. As more patent applications are filed online, it will be easier for machines to read them and find similar documents amongst the millions already in the databases. By the time a human examiner looks at the application, AI might already have given them a substantial head start. In that context, I would like to tell you something more about a very recent report which has been conducted by the Cardiff University. And in that specific report, there has been published a research study to understand the feasibility, the technical complexities, and effectiveness of how AI solutions could benefit the patent office during prior art searching of patent applications. And the result of that specific study, it has been published in April 2020, so just 2 months ago. And the result of that specific study is that the study carried out by the Cardiff University shows that different state-of-the-art AI algorithms can be used to retrieve the closest documents, rank relevant documents, suggest synonyms, suggest classifications, clusters, and visualize the retrieved documents and concepts. However, you must understand that an AI-assisted search will require a patent examiner to manually formulate a search statement. There are currently no effective AI algorithms which can automatically process the application and generate a search statement, which is one of the most important and knowledge-intensive parts of the prior searching process. The construction of the search statement requires a clear understanding of the critical subject matter and the potential novelty of the patent application. And this should remain a human task according to the study carried out by the Cardiff University. So at the end, I will say there will be a big step forward in AI in the patent process, but we need more time to develop better quality AI algorithms. But I assume that in the near future, AI will play a very important role in the patent process, especially on the side of the preparation of the prior search. And you can imagine that if the big 5 IP offices continue with their cooperation and they stick to their vision, which means high quality and examination results and the elimination of duplication of work, that the number of examiners in those big 5 IP offices will be reduced. Thank you for your attention.
Thank you, Ari. In your opinion, going back to this, what's the greatest benefit of AI to yourself as a patent attorney?
The big benefit from my perspective is that there are better quality search reports, and better quality search report will automatically result in stronger patents. And another aspect is that there will be an acceleration of the patent proceedings, and that will also reduce the number of incomplete search reports. The more consistent search reports in the world are really necessary. It is always frustrating when we file an application in Korea and we file the same application in Japan, and we will get different search reports. By the introduction of AI, there will be no difference between a search report created in Korea or in Japan, because the AI algorithm is the same. So the quality of the search reports will dramatically increase, which means that there will be no weak patents anymore. And that's beneficial not only for the patent attorney, but also for people who would like to have an opinion about the validity of the patent. Thank you.
Thank you, Ari. So Ari's been through the patent and search processes and how AI can play a part. So how can these challenges be overcome in terms of delivery? You'll hear from Alex on this shortly. However, just beforehand, let's take a second poll. And the poll details will be coming up shortly. And the question is, have you used relativity for e-discovery? It's a simple yes, no answer, and the results should be coming through in a few seconds. So the answer is 30% have actually said yes, and 88% have said no. So very interesting, and thanks very much for participating. To explain more in respect of this particular topic, I'm now going to hand over to Alex.
Hi, everyone. This is Alex Yanuszewski. So following on Ari's presentation about AI tools, we wanted to give you an example of such a tool. So this is a plugin for the Relativity e-discovery platform. I'm going to do 3 things. First, I'm going to give you a bit of a framework and background on what this tool is supposed to do. Then we'll see a demo of the tool itself. And lastly, for the last portion, I'm going to talk a little bit about the terms AI, ML, machine learning, how they're used, and what it is that these algorithms can be used for to make all of us more efficient. So let's start first with the e-discovery platform. So this is the typical workflow for litigation translation. So you have documents, they are loaded into their electronic documents that are loaded into an e-discovery platform. The first thing you need to do is to identify and segment the languages. So by that, I mean, if you're trying to get everything, let's say, for example, into English for your reviewers, you want to identify what languages there are in each piece of content. And there could be several of these languages. Then you send everything over that is non-English, if you're, let's say, going into English, for machine translation. After machine translation, the documents come back, and there's a facility in the plugin that allows you to mark documents as being responsive or being hot documents. Typically, a much smaller subset of what goes to machine translation in step 2, you actually use for human translation in step 4. Right? So once you mark the documents as responsive, you could send them off for human translation. We, in fact, would do the human translation with a certified expert, do the translation, give you this certification document, and then you could use those documents in the e-discovery platform for production. So that's the typical process that most clients use. And the biggest advantage of it is machine translation, which is ultimately driven by machine learning algorithms, allows you to do the first pass more quickly and in a more cost-effective fashion. So let's talk a little bit about the sort of features that you see in this plugin. So it's a direct plugin that we have, as I mentioned, for the Relativity e-discovery platform. It gives you 4 modes of translation, ranging from light post-editing to ultimately human translation certified, which you would use for production. We could do either an on-site or a cloud deployment. Obviously, for a lot of clients, it's very important. Security, confidentiality, data not getting out of their 4 walls is quite important. That's why we do on-premise deployments as well. So what are our differentiators? And you'll see some of these in the demo. We do customizable neural machine translation. You'll see on the next slide, right, that's a very important factor. One other thing that, as far as I know, we're really the only ones doing this, is language identification on a sentence level and reassembling in the correct order. So the plugin is clever enough to say, okay, if we're translating into English and you have English, French, and German, well, you don't need English translated, you already know what the answer is. We tag each sentence for French and German, and then we reassemble everything in the correct order. Another nice thing that we do is called GDPR compliance analysis, where after we do the translation, we can find entities, names of people, names of companies, emails, currencies, addresses, and that may help you decide if there's a violation of GDPR. There's a very nice dashboard that allows you to see reports by client, matter, and workspace, both for internal and external billing. And last thing, you get email notifications. So typically when you're running machine translation, you're running hundreds, if not thousands of documents. And frankly, watching them all come in on a rolling basis is about as exciting as watching paint dry. So the nice thing about email notifications is you're doing your other work, and when the request is fulfilled, you'll get an email notification telling you to go ahead and go into the system and start working. So I was talking a bit about training a machine translation engine, a neural machine translation engine. So what does that mean? Let's take something fairly innocuous and innocent, like the word driver, right? A driver can refer to a golf club. It can refer to a motor vehicle operator, or if you're dealing with IT, it can refer to a device driver or a printer driver. So as you can imagine, if you're doing a matter that involves, let's say, Dell or HP or Canon, you certainly don't want to be translating driver as a golf club, because it's simply not going to make any sense. So what's important is that we can take data, we can take seed sets, and we can customize the machine translation engine to give you even more relevant and actionable output. So last slide before we actually go into the demo. So this is the round trip that we're going to see in the demo. So imagine you have text. It has some languages in it that are non-English. We're going to identify all of the languages in there. All of the, in parentheses, we have the number of words for each language. We'll ultimately translate. You'll see the status that says it was translated. And lastly, you'll see the GDPR compliance analysis, where once we've done the translation, you'll be able to see the entities that we pulled up. So just a bit of a background. This is I'm not doing a live demo, and the reason for that is as Murphy's Law, things can go wrong in a live demo. So you'll see basically my recording of this a week ago. So it's exactly the same functionality, the same voice telling the same jokes. So hopefully you'll enjoy it. It's about a 5-minute demo. After the demo, I'll stop and we'll go back into the presentation on AI and ML. This is a demo of the Park Relativity plugin. I'm going to show you two different modes of interacting with the plugin. One is the on-the-fly widget mode. The other one is the batch operation or mass operation mode. Let's start with the widget mode. Let's say you're a reviewer and you're going along and you see a document in some language that is not English, as we see on the screen here. What you could do is you could simply click on the document. It will open up in the viewer. We're going to go to the extracted text view, and you'll see the left side of the panel, of the two panels, has the original document. The right side will have the translation when it's populated. You can choose either some of the document and select it and translate it, or you can translate the entire document. Typically at this point, the entire document is selected. We press the Translate Document button, and within a matter of a few seconds, depending on the size of the document, we'll get our translation. The greatest advantage of the widget mode, of course, is that you can get your translations instantaneously in real time. The disadvantage of it is that you're doing one document at a time. So if you have hundreds, if not thousands of documents, it's better to use the batch operation mode. If you have a handful of documents, you can use the widget mode. Also, to point out, as we're in this view, in this extracted text view, documents that have already been translated can be displayed here simply by going back and forward in our list. So we see here that the document was translated. So let's go ahead and do mass operation or batch operation. So I'm going to use the same document, this one called RU, that doesn't have a translation. Also, I'm going to choose a document that we already have a translation for, which is this one over here. You see the translation in the translated text field. And I'll show you why I'm doing that in a moment. So I'm going to choose this document. I'm going to choose the document we want to translate. And here I'm going to go to machine translation. So I'm going to press go. A new dialog box will open up. And as you can see, the software is clever enough to say, wait a second. This document called PTBR, it's already been translated. By default, I'm not going to let you do that again. So that's a nice time-saving and cost-saving device. In our case, we're not going to retranslate it. We're simply going to translate the initial document. So I'm going to press translate, and it's going to take about a minute and a half for this to come back. While this is cycling through its translation, let's take a look at the dashboard. So you can see over here, as we cycle through the document, it says added to the translation queue. So each client, if we go here to Park Relativity widget and settings, each client has their own unique ID. This ID is connected to a dashboard, and the dashboard is connected to a subscription. So in this particular case, we have 250,000 words that were purchased. Here's the start date, the end date, the number of words remaining. The icon green says everything is okay, the subscription is up to date, and we have enough balance remaining to translate. Usage shows you the number of words being used, both as an absolute number and percentage-wise. So the dashboard is a nice way for you to see where you are in the subscription. Lastly, here under profile, you can indicate your emails, and anyone who is indicated here will receive an email when the project is done. So let's go back here and refresh. And here we are. The text has been translated. So let's talk about a couple of things here that you see that are very convenient. One is you see the different languages. So Russian, there were 29 words, Spanish 30 words, Chinese simplified 15 words. The status tells us that it was translated. It was done using a generic machine translation. This can be customized as necessary. Finally, we have our text and we have our translation in English. Now we could reindex this and start running DT searches and keyword searches. Lastly, you see another optional item that we have, which is called GDPR compliance analysis. In this case, once we've done the translation, we've identified an entity, an organization called Luminix Support. Again, this is a nice marker for reviewers. Perhaps this might be a violation of GDPR. Once you've obtained the machine translation, you could run DT searches and keyword searches. If you find something that's salient, you could take the machine translation and send it over for human translation. You would check the same document, and this time when you go to the menu, rather than choosing machine translation, you would choose human translation. Press go. A dialog will open up, and you could go ahead and send over the translation for human translation certified by pressing the translated button. We would receive the file, give you a quote, and proceed with the translation. Thank you. This concludes the demo.
Alex, I have a question. How would the user initiate a human translation via the tool if required? Would this be automated through a system, or would it be administered offline?
So the request, as you saw in the last part of the video, the request would happen through the system. We would get an email notification on a secure share file. We would quote, the client would approve the quote, and then we would commence with the job. Now, the thing that's very convenient is when the human translation is done, the client doesn't need to call us and say, when is this going to be finished? Once it's finished, it automatically flows in via API request into Relativity. The client gets an email notification, and everything is updated in the eDiscovery platform through the plugin. And what's nice is that you get two links for the original native document and the translated document, and any reviewer, attorney, paralegal just has those available as downloads to their local drive. So let's go ahead and go into the next part, which has to do with AI and ML. So there are going to be about 5-6 slides explaining what AI and ML is and how it's used. So one thing from the standpoint of someone who is a practitioner of machine learning, one thing that we see in the mass media is that AI, artificial intelligence, and ML, machine learning, are typically conflated together and used as synonyms. In reality, they're not synonyms. So I wanted to kind of explain a little bit how each of these components work. So basically, the overarching umbrella, the bigger circle here, is AI, which is artificial intelligence. In essence, AI means that it involves machines that can perform tasks that are characteristics of human intelligence. Now, machine learning is basically the ability to teach a computer how to learn, how to generalize without being explicitly programmed. So it's a set of different algorithms that will allow a computer to learn, and then ultimately the computer will give us predictions. Within machine learning, there is a field that you may have heard of called deep learning or neural networks. So neural networks are basically also a set of machine learning algorithms that are modeled loosely after the human brain, right? Kind of the way neurons work in our brain. It's the predominant methodology to train machine translation engines. So I want to explain a little bit how neural networks work. So one thing that's very important is the context. Right? So if I show you this on the screen, and if I were to ask you what it is, you'd probably fairly quickly say, okay, this is a dog leash, right? And if I say, what do you use it for? You would say, well, it's a dog leash, so you use it to walk a dog. Now, if I asked you to stop a second and try to retrace in your brain what took you less than a second to give an answer to, right? You would probably say, okay, so what is this thing, right? What's the context? What is this thing? How is it being used and by whom, right? So you might say, okay, well, if it's a dog leash, sorry, if it's a leash, you know, generally speaking, I'm not going to use it for a fish nor for a bird, right? Because you're not going to be using, neither one of those two animals can be walked, right? So presumably it's going to be some sort of a mammal, right? Now, if you begin to think about mammals, you're generally not going to be walking down the street with, let's say, a hippopotamus or a rhinoceros or you know, an animal of that sort, or a giraffe, for example. So that begins to further narrow down your field. So you might say, okay, well, what sort of domestic animal would I walk, right? Would it be a cat? I mean, probably not, right? Because the probability is that a cat doesn't want to be walked and is going to scratch you, right? So most likely it's going to be a dog, right? If you could conceivably walk a ferret down the street or a lizard, but that's, you know, very unlikely. So ultimately you'd arrive at a dog. And essentially that's how a neural network works, right? It basically takes a sentence, here it is in German, and it builds up meaning that's represented by numbers, right? And each number represents a context, a feature. And all of these taken together ultimately yield a good translation, right? So that's in a nutshell, that's how neural networks work. So I wanted to talk a bit more about machine learning algorithms because basically I like to think of it as cooking, as like you're preparing a meal. So you have, when you cook, right, if you want to make a meal properly, you need to have the right ingredients in the right proportion, right? So our ingredients here are data. We want to have data that's as clean as possible. We couple that with machine learning algorithms, and ultimately we train a model that will allow us to do prediction, right? It will allow us to say, okay, if I give new data to this model, it will give us some new insight, right? Now, why are we doing all of this, right? What are the business outcomes? Basically, we want to improve processes from a technology perspective. And Ari alluded to this in his talk as well. Ultimately, we want to lower cost and we want to improve the productivity of people who are working with these technologies. Right. So I wanted to give you some examples of, so NLP stands for natural language processing, right? It's basically taking the natural language, so not computer language, but the natural language that we as human beings use that can be used for text processing. So I wanted to kind of explain what we can do with text, because now with neural networks and machine learning algorithms, there are lots of insights. So first on this slide, I'm going to show you the pipeline. And on the next slide, I'll give you some examples of what we can do with this pipeline. So basically here, we have text, right? Once we take this text, we can do language identification and detect what language the text is. Is it English? Is it Chinese? Is it Japanese? Is it all of them together? So we need to split each one properly. Once we've identified the text, we can now begin to split the text into individual words, right? And that's what's called sentence segmentation and tokenization. Now, once we've split the text into words, we can start doing all sorts of other things. We can start looking for insights on this text. So we could do GDPR compliance analysis, like I showed you. We could do neural machine translation, as you saw in the demo. You could do other things like doing term mining. You could look for salient keywords. You could look for relationships between words and concepts, and you could look at sentiment analysis. So let's take a look at these items here in the gray boxes on the next slide. These will give you really salient examples of what you can do. So GDPR compliance analysis. Imagine you have a sentence like this. Apple is looking at buying a UK startup for $1 billion. There's lots of nice insights here, right? We have the name of an organization. We have the UK, which is a geopolitical entity. And then we have 1 billion mentioned, which is a currency, which is money. Right? So this gives us ideas about whether this could be violating some sort of GDPR precepts or not. We've talked about neural machine translation and the idea of driver, right? That if we're doing IT, we certainly don't want to be translating a motor vehicle operator or a golf club. Now, sentiment analysis, it's also called opinion mining. This is very nice. And here are some very, very extreme examples, right? In the first one, I say that Alex is very smart, handsome, and funny. And basically, this is judged on a scale from -1, which is very, very negative, to +1, which is very, very positive. 0 is neutral, right? So you can see that this is clearly a very positive sentence, and that's why it has a score of 0.93 on a scale of 1, right? Now, in contrast, if I do the opposite and I put a negation in here, and Alex all of a sudden becomes not smart, not handsome, not funny, you can see that this number becomes -0.74. So it's very negative, right? Now, this is very, very useful And it's used in a lot of applications. It's used, for example, in the financial world to try to predict where a stock is going to go, depending on what people are saying in stock reports, right? But you could also, this is very, very, very much used in litigation if you want to see what people are saying about a particular product, right? Now, keyword searches, here's a nice example of a word cloud. So this is a top pharmaceutical company that was recently sued in a class action suit for the side effects of one of their drugs. And what I've done here is I've taken the most salient keywords associated with Twitter feeds by people who suffered side effects, and I've plotted them. And the larger the word is, the more problematic the side effect was. So you could see here, for example, something like allergy is relatively small, or dizziness is very, very small, but you can see, for example, pelvic pain or bleeding is quite large, right? So this is a way for us to see insights between words. Now, the last one is relationships between words, right? So once we've broken up a sentence into individual words, we could look for relationships. So here's an example for the word London, right? For the proper town, London, right? It is governed by a mayor. It's a major settlement on the Thames. It has a population of over 7 million, and it's a large capital, and it's the capital of England, right? So you could imagine that if you have actors, right, names of people, names of companies, you can find relationships between them and how they interact with each other. So again, thank you very much for all of your attention.
Thank you, Alex, and thank you again, Ari. For those of you who wish to stay on, we'll now move on to our Q&A based on the questions we've been receiving from our audience today. We'll endeavour to answer as many as we can now. However, in the interest of time, we'll happily respond to any further questions that you might have offline. In addition, and for further reference purposes, we've also created a handout for you, which you'll see in the box on your screen. So please feel free to take a look at that, and we'll take a look at some questions now. Alex, I've got a question for you here. Would you be able to give a real-life example where Welocalize's AI solution helped in a case involving e-discovery, and what were the outcomes for that client?
Yes, absolutely. So this plugin that I was showing you, we actually had a client who needed to translate hundreds of thousands of documents. To put it in terms of gigabytes, this was close to 10 gigabytes, and it had to be done in about 3-4 days, right? And the plugin gave them the facility to do so. I mean, we're talking about in excess of 200 million words, right? So that gave them the first pass. And then basically about 3-4% of those documents were subsequently sent over for human translation for production, right? For use in court proceedings. Now, to give you a sense of the cost saving and time savings, if you had to do over a couple of 100,000 documents by human beings, even if you assembled a team, it would take literally over 2.5 months to do this by a human being, as opposed to doing it in 4 days. The other aspect is cost. If you had human beings translate over 200 million words, the amount of money that you would spend would be well into 3-4 million, right? Whereas with machine translation, this was literally done at a fraction of the cost.
Great, thanks, Alex. I have a question for Ari. Ari, for customers interested in using AI in the patent process, what would the next steps be?
Okay, in my presentation, I was more talking about the aspect on the government side, because the government is creating the search report. But you can imagine that for customers interested in using AI, the commercial companies, they will start offering search engines which use AI. If you look, for example, in India, there are a lot of search companies who you can ask to do a search for invalidity or novelty search, and those firms, they use AI in order to retrieve the relevant documents. So I think that in the next future, the quality of the searches, even produced by the patent office or by a assumed infringer, will increase in quality.
Thanks, Ari. I have another question for Alex. Alex, how acceptable is machine translated content at litigation?
So what we're seeing right now, it depends on the language, and typically, just kind of to paint with a broad brushstroke, European languages, especially Romance languages, tend to do quite well. So we're seeing, we refer to it as actionability, meaning that it may not always be absolutely grammatically correct, but you can have a sense of what you need to take the next step, right? So for Romance languages on generic engines, we're seeing 75 to 80% actionability. For Asian languages, hovering around the 70% mark. Now, if the engines are customized, typically we're seeing actionability go up by 5 to even 10%. So therefore hitting the 80s, even for Romance languages, high 80s, even low 90s as far as actionability.
Great, thank you. I have an interesting one here for you, Ari. Can AI be patented? And if so, who would own the rights?
Okay, that's a good question. If you would go for a patent, you have to meet the requirements of the specific law. For example, you have to meet the requirements of novelty, inventive step, but also sufficiency of disclosure. And regarding the wording of the claims, they should be clear and concise. And you also need to provide a fully detailed description. Recently, under the European Patent Convention, AI as a method was excluded from patentability when claimed as such. However, if you direct a claim to a method involving technical means, for example, a computer or to a device, its subject matter had a technical character as a whole, and for that reason, it was not excluded from patentability. So basically, in Europe, it's possible. In the US, it's much different because there are different opinions about that aspect. There was recently a case in which a company, they filed an AI invention, and that was refused by the patent office because the patent office was of the opinion that they did not accept the application because the inventor as such can never be a machine. The inventor in an application has to be a human being. So for that specific reason, the application was not accepted and was rejected. And there was a similar application filed in the USPTO, and they also applied the same argumentation. The USPTO said, under the current law, only natural persons may be named as an inventor in a patent application. So under current law, only natural persons may be named as an inventor. So if you file an application in the name of an AI system, such a patent application will not be allowed based on the fact that the law at the moment does not provide any provision for a machine as an inventor, as an owner.
Great, thanks, Alex and Ari. Alex, I have another question here. Bear with it, it's quite a lengthy question. From a translation perspective, as MT becomes more advanced, especially with advances in neural machine translation, do you think that we will one day see patents being translated with MT, even with minimal post-editing?
I think we'll see patents translated with MT. I still think the human component will be quite important. I don't think we're ever, to be clear, I don't think we're ever going to get rid of a human being. I think what we'll be able to do is make a human being do work that's more meaningful and less rote and make them more productive. So I think as MT becomes stronger and more actionable, you'll see people being more productive, but we'll still always need a human component to make decisions because there are some linguistic things like polysemy that a human being only can do and a machine will have a very, very hard time doing.
Right. Thanks, Alex. Just looking at the time, we'll take one final question, and apologies if we didn't get to yours during this session, but if you'd like to find out more, please feel free to contact us at the details on your screen. Ari, the final question we have here is, one of the points mentions that AI can improve quality of granted patents. In what respect and how?
Okay, thank you, Chris, for your final question. It's difficult to identify what does quality means, but if we identify quality as weak and strong patents, I am of the opinion that the quality of the granted patents will be improved by AI because, as mentioned in my talk, if you have a high quality search report, which means that all the relevant documents have been taken into account during the granting process, you can imagine that only the strong inventions will survive. So the search report is a very important thing in providing a granted patent. If you look at a weak patent is, in my opinion, a patent which can be easily invalidated by anyone. And invalidation of a patent application takes place by submitting relevant documents to the patent office, which have not been exempt by the patent examiner. So I think that by the introduction of AI, the number of weak patents will be reduced dramatically due to the high quality of the search report.
Thank you. Thank you very much, Ari, and thank you, Alex. And thank you to everyone for attending our webinar today, which we hope you found useful, and we hope to welcome you to the next Welocalize event. Enjoy the rest of your day.